The surface resistivity, or SR meter, measures the surface resistivity of concrete, an indicator of its permeability. This video refers to AASHTO test method T358-19. This video covers the operational aspects of the device only, not the scientific details of how the device works. For this demonstration, we are using the SR meters inside our Mobile Concrete Technology Center. This video demonstrates how to use two such devices. These devices are not the only SR meters in the market, but they are presented because they are available on loan to agencies and contractors through the FHWA's Mobile Concrete Technology Center. The ProSec device has an internal battery and takes one measurement at a time. The Geotech device is plugged into an outlet and takes measurements from 4 different locations simultaneously. The SR meters utilize a 4x8 cylinder for testing. Other sized cylinders can be tested too, as long as the appropriate adjustments are made. In this video, we will be showcasing testing on 4x8 cylinders, so we will be following AASHTO T23, or ASTM C31/C31M, to make the cylinders. Immediately after you remove the concrete sample from the mold, mark the top finished surface of the sample with a plus across the entire surface. Extend these marks down the sides of the sample in straight lines, thereby identifying 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Mark the longitudinal lines of the sample like so to help you center the meter. Whether it's a mark in the middle or a mark on one edge, it will help you line up the probe. To turn on the meter, simply press the top button. Before using the device, verify its accuracy by pressing the 4 sensor tips onto the provided calibration board. There are 2 rows, which should show as 12 and 90 kiloohm centimeter respectively on the device's screen for the 4x8 setup. Place roughly 1/4 inch of water in a shallow container nearby to use in the ProSec test. First, attach the cables from the probe array into the back of the main device. Follow the numbering shown on the ports and cable ends. Plug in the meter, then turn it on by pressing and holding the power button. Press the 3-line button once to enter the menu. Then press the enter button to enter the test method menu. From here, select either the AASHTO or ASTM specification, depending on which one you will be using. Now, place conductive gel on each of the sensor tips. Now that your device is ready, take the cylinder from curing and bring it to saturated surface dry conditions. To do this, you can roll the cylinder in a damp cloth. Place the cylinder sideways on a non-conductive stand, such as plastic. Wet the tips of the sensors by placing them into the nearby container. Start with the 0 degree line and press down the ProSec meter so that the springs in all 4 probes are compressed and the sensor tips are flat against the surface of the sample. Repeat this process for each of the 4 lines once, then continue around the sample and take measurements from each line a second time. Record your measurements, either by hand or by pressing the bottom button on the device. Multiple sets of data can be stored in this device. For more information, refer to the manual. Place the cylinder into the plastic container, centering the probes on the 4 longitudinal marks with the 0 degree line facing you. Close the lid of the device, then press the Enter or greater than button. The device will then give you 8 numbers, 2 from each set of sensors. It will also calculate the average. Record your measurements by hand. To record multiple sets of data, connect the device directly to a computer. When looking at the results for either device, the method of curing is important. When comparing SR data, it is important to have the same curing conditions, as lime water curing can reduce the measured resistivity by an average of 10%. Instead of using water in a container for the ProSec meter, you can place a wet cloth nearby to wet the tips of the probes. To achieve saturated surface dry conditions for the sample, you can roll it in a damp cloth after pulling it from curing. The temperature of samples during testing is also important for consistent measurements. It is best to keep them between 20 and 25 degrees Celsius, or 68 and 77 degrees Fahrenheit. For more videos of other concrete materials and construction-related technologies, visit our website.